Hello students, this is Mrs. Youd, and today for my Math 8 class, I'm going to do Chapter 3, Lesson 4, which is all about using similar triangles. Please have out your spiral notebook, open up to a nice clean page, and write this title at the top of the page. So if you remember back in Chapter 2, Section 5, we learned that similar figures have the same shape, but not necessarily the same size. So in these two triangles, if I told you the triangle ABC was similar to, remember this symbol here means similar to, triangle DEF, then what it means is that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, because those are the corresponding angles in these two triangles here. We also learned back in section 2.5 that the side lengths are proportional. So the side length of AC over the side length of DF, for example, would be equal to the side length of AB over the side length of DE. So for section 3.4, we're kind of using this idea. So we're going to start with this concept. When two angles in one triangle are congruent, remember that's a different way of saying equal, to two angles in another triangle, there are two things that happen from that. The first thing that happens is that the third angles are also congruent. And the second thing that happens is that the triangles are similar. All right, let's look at an example that has to do with this. In this example, we need to tell whether the triangles are similar, and we're given two triangles here. So my first step is to find out what x and y are. So let's focus on this first one and find out what x is. Remember that from the last section, section 3.2, we learned that the angles in the triangle add up to 180 degrees. So what I'm going to do is use that information to help me find x. So I know that 54 plus 63 plus x is equal to 180. So if I add 54 and 63 together, I get 117. So 117 plus x equals 180. Now we just need to subtract off 117 from both sides, and we get that x is equal to 63. So that means this angle here is 63 degrees. Now, when we look at this, we see that we have a 63 degree here, and we have another 63 degrees. Over on the other triangle, we have a 63 and a 63, which means that these two triangles are similar. So my answer is the triangles are similar because the angles are congruent. For example B, we have two triangles again, and we need to find out if they are similar. Last time we solved for x. This time, let's solve for y. So I'm going to set up my equation, y plus 90, remember this is 90 here, plus 38 is equal to 180. Once again, we need to combine like terms. So 90 and 38 is 128. So this is 128 equals 180. To finish solving, I'm going to subtract 128 from both sides, and I get my final answer of y equals 52. So that means this equals 52 degrees here. So let's take a look. We have a 90 degree, and that's shared with this 90 degree. 52 and 42 do not match though. So that means my answer is the triangles are not similar this time because the angles are not congruent. Please open up your RPJ to page 66. In this problem, in these four problems, we need to tell whether the triangles are similar and explain. I'm going to do number 2 and number 4 with you, and then you are going to try number 1 and 3 on your own. So let's go ahead and take a look at number 2. We have two triangles. We need to find either y or x. Let's go ahead and solve for y this time. So I'm going to set up my equation, all three angles, so 52 plus 40 plus y needs to equal 180 degrees. So now we need to solve for y. So if I draw my line and circle my variable, I notice that first I can combine like terms. 52 and 40 add up to 92. So we have 92 plus y is equal to 180. Now we need to finish by subtracting off the 92 from both sides so that we get the variable by itself. So y is going to equal 88. So let's see what we have here. If y is equal to 88, I'm going to write that up here. That means that we have a 52 there, and we have, so 86 and 40. The 40 is the only one that they share, but then we have 86 and 88. So that means that they are not similar because the angles are not congruent, and that's my answer. Okay, let's take a look at number 4. Last time we solved for y, so this time let's solve for x. So I'm going to set up my equation. X plus 55 plus 90, remember this box means 90, equals 180. So once again, I need to solve for x. I notice that I have two like terms that need to be combined. So when I combine those together, I get 145. So this is x plus 145 equals 180. My last step is to subtract 145 from both sides. And so then I get my final answer of x equals 35. So that means that this angle here is 35 degrees. All right, let's take a look. We have 90 and 90 that they share, and 35 and 35 that they share. That means that these two triangles are similar this time. So I write my answer, yes, they are similar because the angles are congruent. I would like for you to do 1 and 3 on your own. Pause the video and then turn it back on when you're done. For number 1, I got yes, they are similar because the angles are congruent. I went ahead and solved both for y and for x because you could have solved for either. You did not need to solve for both, just one of them. On number 3, I got not similar because the angles are not congruent. Again, I solved for y and x, but you only needed to solve for one. For the last problem, you can use similar triangles to find the height of a tree. Triangle ABC is similar to triangle DEC. So here we have ABC is the big triangle, and that is similar to DEC, which is the small triangle. So what is the height of the tree? We're trying to find out what x is. When you are doing these kinds of problems, I find it helpful to sometimes move the triangles and pull them apart from each other. So here's what I mean. This big triangle ABC is this same triangle here with the tree, and this small triangle DEC is the same as this smaller triangle with the man. So if I think about what I know or what I don't know, this height of the big triangle is x, so I'm going to put an x here. This length of the big triangle is 9 plus 6, so the whole entire length is 15. So I'm going to put a 15 here. The height of the man is 4. Well, sounds like a boy actually, because that's a little bit short. So the height of the boy is 4. And the length from E to C is 6. So this length here would be 6. All right, so now we have our similar, what we can do is use these similar triangles. If you remember back in chapter 2, we learned that the side lengths are proportional. So I can set up a proportion. And what I want to do is think, okay, x goes with 4. So I'm going to put those together, x and 4. And 15 goes with 6. Now, since I started with big triangle on the top of the fraction, I need to continue with the big triangle on the top over here. So that means 15 would go on top over 6. Now, hopefully you remember what to do. We can do cross product. So this is going to be 4 multiplied by 15, which is 60. And then on the other one, we have x multiplied by 6, which is 6x. And now because they are similar, we can set those to equal. So 60 equals 6x, Now divide by 6 on both sides. 60 divided by 6 is 10. So that means the height of the tree is 10 feet, and that is my answer. Okay, that's it. Thanks for watching.